Hi, welcome to Paultre on Power System Design podcast on the latest in power and power design. This is a special live version done at the Design West conference, and I'm here today with John Carbone. He's the Vice President of Marketing for Express Logic. So hi, John.
How you doing, Alex? Nice to be here.
Glad to have you here. A lot of people forget that energy efficiency is not just hardware in the hardware design, it's also a lot about the software and the software design, correct?
You bet. The software can dictate energy consumption in the system that's being controlled by the software in a number of ways. In particular, the real-time operating system plays a significant role in the power consumption of a device. First of all, the amount of memory occupied by the operating system dictates how much memory as a minimum the system must contain. And in something like an SoC, with limited on-chip memory, the amount consumed by the operating system is very important, and if too much is consumed, it'll push the requirements over the limit, perhaps requiring access to external memory, which would require even more power consumption.
Is it just a system architecture thing? Is it just a chip architecture thing, or are there actually things that the RTOS can actually do to enhance the efficient operation of the system?
Yeah, one of the things that we've done in ThreadX, in our real-time operating system, is in our scheduling loop. Whenever we detect that the application is idle, there's no active application thread to run, we automatically put the chip into low power mode. And for the Cortex-M3 and Cortex-M4 and all the whole Cortex-M series for that matter, there's a simple operation to do that. That's zero overhead. So we can bounce in and out of low power mode for every perceptible gap in performance requirement. So every time the application hits a cruising state or an idle state waiting for something to happen, we can go to low power and save a significant amount of power as over the life of the application.
Couldn't that also though be addressed with just simply setting up your duty cycles properly, or is it necessary, or is it just desirable to have an RTOS manage that?
Well, it's extremely difficult for the application to figure out when there are other parts of the application that are running or not running. That's the job of the operating system. The operating system inherently knows the information about when each part of the application is running. And so if the operating system knows that nothing is running at this moment, then it can go in low power mode. For the application to figure out that no other part of the application is running would be quite complex and effectively duplicate the functions of the operating system in order to just figure that out.
Exactly. Now, I understand that you're actually deployed in quite a lot of platforms. Can you tell us a little bit about your extended base?
Yeah, a lot of our business is in the low power area, and for example, one of our more popular consumer products is Apple's iPhone. And in the iPhone, there are multiple subsystems, each controlled by an SoC, which collectively operate under a very tight power budget, as you know, for extended battery life. And the subsystems include things like baseband radio, Wi-Fi, and Bluetooth wireless communications. Each of those SoCs uses ThreadX to control the functions of the software-defined radios in each of those application areas, and collectively deliver all those functionalities to the iPhone and the iPad and similar ARM-based products in the wireless communication space.
Now, is this something that is best for a very complex system, or can a simple system also take advantage of the functionality?
ThreadX is really geared towards relatively simple systems. The SoCs are very singular in purpose. They work on baseband radio, and for a function like that, it's very simple. They need a very lightweight real-time operating system. For the main processor in an iPhone, for example, by comparison and contrast, the iOS operating system from Apple is a very complex operating system with sophisticated user interface graphics and all kinds of other functionality, application downloads and the like. And that would require a much, much larger footprint that would not be practical to put into multiple SoCs within the iPhone.
Exactly. So basically, you're sharing off the unessential portions for the iOS and the critical infrastructure our real-time operating system manages.
Exactly. We do special purpose functions, and there happen to be several of them in the iPhone, but this is just typical of devices. Medical devices, handheld medical devices, for example, industrial control equipment, anything that's battery powered is going to have a similar challenge. How to do a number of different functions without consuming too much power. And so generally the designs center around low-powered SoCs with hardware that can consume little power and software that doesn't force the hardware to be larger than it has to be or faster than it would have to be. So a small footprint, efficient, real-time operating system is appropriate, and that can enable modest processors like a Cortex-M0 to really deliver the goods in many of these applications.
Excellent. Well, John, is there anything else you wanted to leave our audience with about your systems before we close out the episode?
Well, if they're interested in learning more about ThreadX or ExpressLogic, visit www.rtos.com, RTOS.com, a place to go for real-time operating systems, and I hope they see something there that piques their interest.
I think they will. Thank you very much, John, for being with us today.
Thanks, Alex.
I'd like to thank all of you out there for taking the time to watch us. We wouldn't be here without you. Tell your friends. This is Alix Paultre for Paultre on Power. Have a great day.